So for this problem, it's already factored out for us. And this is basically saying that we have one of these. We have 3 of the x plus 3, 1 of the x minus 5s, and 2x squares. It's already factored, so it's in factored form. So when it's in factor form, you basically have to add up all your exponents. If it doesn't have an exponent, you put a 1. So 2 plus 1 is 3, plus another 3 is 6, plus 1 is 7. So that means that my degree of this polynomial is 7. My leading coefficient is positive, since I have a positive 3 and everything's being multiplied. So my leading coefficient is positive. That tells me that it falls on the left and rises on the right. And now all we have to figure out is what's happening in between my function on my graph. So what I like to do is I like to make a little chart and kind of put my thoughts and know what's going on. So what I like to do is identify all my zeros, my multiplicities, and my end behaviors for that specific zero. So again, when we find our zeros by making each binomial or monomial equal to 0 by using the zero product property. So if you make this equal to 0, you're going to get that x is equal to 0. You make this equal to 0, and you're going to have that x equals 5. The next one would be x equals -3, and x equals +1. Once you have that, all you have to figure out is your multiplicity. How many of that happens? So we have a double because we have squared. So that's a double. X minus 1 to the 1 power, that's a single. It only happens once. X plus 3, that's cubed, that's a triple. And x to the 1 power again, that's a single. Something I don't think I mentioned in class, anytime it's an even power, it's going to bounce from that x-intercept. Anytime it's an odd power, it's going to cross. But we just need to figure out how it crosses. Does it cross as a straight line? Does it cross as a, as something that looks like cubic? So this is why we're looking at the end behavior for that function for that specific point. So because it's a double, we know it's going to bounce. So, it's going to either look like this and it's going to bounce, or it's going to look like this and it's going to bounce. Where for a single, it's going to cross and it's going to be linear. So like a linear function. And for a triple, it's going to cross also, but it's going to be more like a cubic because it's going to have that little cubic curve that we usually have. And then again, we have a single, so it's going to cross. Think of a line. So I'm trying to give you visuals so you understand a little bit of how the sketch will look like. Okay, so let's start by putting in our zeros. So we have a 0 at 0. We have a 0 at 5. A 0 at -3. And at 0 at 1. Okay, so after that, we're going to sketch. We know that on the left side, it is falling. And at -3, it crosses something that kind of looks like a cubic. And then at 0, it bounces. So it's going to bounce. It's going to touch that point and bounce. And then at 1, it's a single. So when it bounces, it was going to bounce up and then it's going to cross down. It's kind of straight. A little bit more of angular, I think. So maybe it's more something like that. I'm not the greatest sketch artist here. And then at 5, it's going to cross again. And it's a single, so crosses up. I think you guys could probably do a little better job over here than me, but I have issues with drawing up apparently. So then that would be your graph, a sketch of it. And then the last thing to figure out are relative max and mins. So this is a relative max, this is a relative max, this is a min, and this is a min. I think in class this was a little shorter when I did it in the notes. The height of these at this point doesn't really matter because they're sketch, but these are maxes and these are mins. So the number of relative maxes, we have 2, and number of relative mins, we also have 2. So for this problem, we need to factor it because it's not in factor form. So after we figure out that our degree is 3, because it's in standard form, it's always going to be our highest degree, and our leading coefficient is positive, then we know that our graph falls on the left and rises on the right. So now we have an idea of how our end behavior of the graph is. Now we just have to figure out how it looks in the middle. So the first thing that we're going to do is factor. Since it has 4 terms, we're going to factor by grouping. So we're going to group the first 2 terms, plus we're going to factor or group the second 2 terms, and there should be a minus there. And we're going to take the greatest common factor from each binomial. So that means the greatest common factor for this one was x squared. That means we get an x minus 1. And we want this one and the second thing to match. And the only reason they don't match is because this right here is positive and this was negative. So what we're going to do is we're going to factor out a negative 1. And now we have x minus 1. And now we have these 2 will be matching. And basically when you factor by grouping, you're taking the greatest common factor out basically 3 times. You're taking out the greatest common factor from the first binomial, the second binomial, and then you're taking the greatest common factor from your whole equation. So the greatest common factor right here would be x minus 1. So our next step would be x minus 1, and then our leftover piece from the first one is x squared minus 1. And this could be factored out further because it's a difference of 2 squares. So now we're going to have that we have x minus 1, x minus 1, x plus 1. And if you really want to see this, we could have these 2 together. It's a double. So you could actually write it as a double. You don't have to. But so you see that it is a double because it's exactly the same thing. Since it's the same thing, you can leave it as 2 separate pieces or write it squared, which means it's doubled. This and this do not mean the same thing. This means I have 2 of a kind right here, 2 of these. And this would be your double, this would be your single. So if I do my little table like we did in the first example, I'm going to have my zeros, my multiplicities, and my end behavior. So I'm going to have my zeros, my multiplicities, and my end behaviors. So I'm going to have x equals 1, and that would be a double because I have 2 of those. That means it bounces. Okay. Then I have x equals negative 1, and that would be a single, and that means it crosses. So if I plot those points, I'm going to have a point at 1, a point at negative 1. I know that my end behavior falls on the left, so it's going to cross it. And then I know on 1 is a bounce, so it's going to go up, bounce, and my end behavior at the right side is rises. So my graph, or my sketch of my graph, should be something similar to that. So for my relative min, for the number of relative maxes and mins, okay, I have one relative max and one relative min, so it's 1 and 1. So I have one relative max, one relative min.